Hello everybody, welcome back to another video. I'm hoping you guys are all having a fantastic day. So as you could tell in today's video, yes, we will be talking about a potentially very large system. Most likely, if it were to occur in the current pattern that is forecasted for that time frame, it would be, yes, a winter storm. Now, I do also want to specify that some models, this is relatively still far out. It's not super far out. This isn't like a La La Land storm that I'm talking about because I want to. It's most likely gonna occur in some way or another. If it does, it's either gonna be a very big singular large system, or some models do show kind of a series of smaller but very potent storms that too would be dropping snow across various locations. So overall, a very active, snowy and cold pattern potentially for a good portion of the northern United States. Obviously not for the south. Even if it is a cold pattern in November, it would have to be a historic pattern to bring snow down to the south in large quantities. Now again, for the north, we don't know where the system will track. If it brings snow to Minnesota, then, areas south and east of the low pressure will be seeing rain, and that includes Wisconsin, Illinois, Michigan, right? So again, wherever it occurs depends on that, and right now I'm just kind of generalizing because we don't know. So there's a lot of stuff to talk about. By showing you several models that kind of show different things, I hope you understand the situation that we are going to be headed into, and what maybe we could expect, and again, why I am thinking that there could be a very large system. So before we get into this, however, I do want to say that if you're new to this channel, first of all, hello, and welcome. Obviously, check out the channel, check out the video, watch the video, see if you enjoy the channel, and if you do, consider subscribing and consider liking the video. As I always say, don't subscribe or like the video just because I told you so, right? It's just a reminder. I do it at the beginning because that's where I guess most people are watching. So obviously, if you don't like weather content, and you won't stay watching. But without further ado, also if you have any comments, leave them down below. I do my best to answer. Some videos I don't because I'm busy that evening or whatnot, but I do my best, and usually it's all of them if I answer them. Okay, without further ado, let me stop talking about useless stuff. Right, let's start talking about this winter event. Right, so there's a lot of excitement, and it is, usually during any winter storm, I'm probably equally as excited, but there's always just something special about the first one of the year. And granted, we've already had one across Wyoming and South Dakota. Again, it was kind of a I don't know. It's just it wasn't. It didn't really feel like a first winter storm for some reason, and this one could be affecting areas, I guess, maybe closer to my area, which is why I feel more excited. I don't know. Let's start talking about this. This is the GFS weather model, Global Forecasting System. It is a very good model, and let me show you what it shows, which is playing through right now. I do want to pause it for a second. You see the stuff going through. You saw that there really wasn't major anything that happened other than the West Coast and southwestern Canada getting hammered, because for the next week it's going to be relatively dry and relatively warm, actually. So you can see here's the timeline, November 10th at that given hour, and you can see this is 138 hours into the future. Again, this is just one weather model, so whatever it shows is not a definitive truth. However, again, no snowstorm most likely in the next kind of week. Around this time frame next week, though, Thursday, Friday, wherever you're watching this, of they say the 4th or the 5th of November, a week from today, there could be our first storm. Now you can see the GFS develops a little system out of this. Nothing too extraordinary, but it does bring some rain, some snow. It does turn on some lake effect onto the UP, but again, nothing too significant. However, it is significant in a sense of the larger kind of picture, because what this system does, it's strong enough to bring in a bit of cool air from the north, and all low pressures across the northern hemisphere, they situated right there. You can see marked 998 millibars of low pressure. That is not particularly strong, especially for a winter storm. And notice it well, you can't really notice, but all low pressures, they spin winds in this style, so it obviously will be bringing in a bit of cooler air. What that does is it supplies enough of that cold air for another wave. Notice this one is much more developed earlier on. It is already across the upper plains. Again, this is Friday according to this weather model. Some weather models don't even show this at this given time. That's how kind of the wide the spread is. But, in terms of forecasting 1 week out, it's not terribly out. That's not terribly far out, and you could definitely start talking about individual storms. Again, just not the details, or Minneapolis, we'll see snow from this, or this city, or that's just too early for that. But you could start talking about the threat, which I'm trying to do in this video. And notice it brings snow for some areas, obviously where it's a bit too warm, it doesn't. Whether or not that's accurate, it's snow to rain kind of line according to this model. It's interesting, but again, it's kind of hard to tell. You can see it brings some snow into Michigan, maybe even some very strong winds, some localized blizzard conditions if this were to occur. Again, it's just a scenario. You can see it drops quite a bit of snow, you can imagine, across the southern Canadian cities of Toronto, Montreal, Ottawa, Quebec, and again, you can see it's not a massive storm, right? Though it's potent. These areas would pick up potentially several, if not maybe even a foot of snow. Obviously, the Northeast would get in rain on that. But the GFS isn't done. You can see it shows kind of this hybrid clipper, turns on the lake effect, and by the way, it does develop it into a beast once it moves off into kind of southeastern Canada. I don't know if I have many viewers from this area, or if I do, which I usually still do kind of reference systems here. This would be a beast. 967 millibars. This is actually stronger than what the GFS was showing the model in prior, which I honestly wasn't even expecting it to strengthen into such a beast. But obviously, that would be pretty impactful. And you can see all the lakes are kind of really turned on by all that cold air, and they are producing just a lot of lake effects. So that's that's more kind of affecting many cities, potentially. Again, those lake effect bands stretching for hundreds of miles. We'll have to see. But look, the GFS, it's not done. Right? Develops that super system, whatever, develops that very strong storm, and then look, there's another one. Again, it's not massive by itself, but it does produce more snow across different areas, and it does kind of strengthen as it moves along, and again, develops into a beast, an absolute beast off the northeast coast or southeastern Canadian coast, depending on which perspective you choose to go from. And again, you can see that mostly southern Canada, regardless of whether it's going to be warm or cooler or the storm track, there's probably going to be snow that's falling. Again, obviously, if it's more of a warmer pattern for the United States, that means more snowy for Canada. If it's a bit colder for the United States, that means the storms are going to ride where that jet stream kind of is. So it's going to be snowier for the U.S. and a bit drier for Canada, but colder. So that's kind of the two potential scenarios. And I don't want to show you these last few hours. You can see that the GFS does keep things active. It just doesn't form another system, but it's formed enough in that time frame. Let's take a look at the morning runs. This was the one prior to the one I just showed you. They come out 4 times a day, and let's see what this one shows. Again, it is very consistent, all the models, that the next week will be dry and mostly storm free. You can see that the GFS does develop that storm that it developed in that one I showed you, the one that was like that beast with that 967 millibars off southeastern Canada. Not as much snow with this model run. It definitely does develop, and it's kind of more of a singular big system. It does start producing snow, and once it does, it could be falling very heavily, but you can see it's more across Canada, not even affecting Toronto, really just north of those areas, even the largest cities, and it does still obviously produce a lot of rain, a lot of precip, but it's just not, it's not kind of a small to large, it's kind of a big one, staying big, and really not allowing any smaller systems, I guess, to kind of form, but you can see that the GFS still does trying to produce either a clipper, maybe some sort of a combination of a clipper and some moisture from the Atlantic Ocean, how like the biggest nor'easters form. It's tough to tell, but again, you can see that it's already kind of just changed its mind with the newer model run because it didn't really show any of that in the newest one. This is the one prior to the one in the morning. This is the one from yesterday at midnight or today at midnight, 12:01 today, 11:59 yesterday. And notice that, again, it's going to be quiet for most of the week other than the West Coast. And look, there's that first system that it develops today into that beast. Look, it did develop it. It's just not as strong. Doesn't have a cold front, though. It does have some snow. There is our kind of main focus, our main storm. You can see it. It's definitely there. Bit of a winter storm. Quite a bit of snow across really far southern locations. So that's interesting. Again, you can see the consistency, right? That there is a storm. There is an active pattern. But the details of how many, where, how much snow. I mean, I wish I could answer those questions, but I literally can't. I mean, if the GFS was consistent, it probably still wouldn't. It would still probably be too hard to answer because, well, there are other models in the GFS. It's not just one model, right? The GFS can be consistent for 4 model runs in a row at this distance, at this time frame far out, and it still wouldn't be enough to be like, oh, let's start making our details because the weather models continuously change. Obviously, they do less and less as we approach in time, but there could be a lot of things that change. snow across, as you saw from that GFS, across Ohio, Kentucky, versus snow that falls north of Toronto. That's quite a big difference, and obviously that pattern that produces that would be even larger of a difference in order to kind of result in that that change in distance and that snow where that snow falls. So let me quickly actually go back to the Canadian, or go back. I mean, I haven't showed you yet. It goes out to 240, so not as far as a GFS. So even if it shows several systems, it really will just have time to show us one because it's 240 hours out. Let's see what it does show up until that 240 and if it agrees with the GFS. Notice, it doesn't introduce any systems across the United States up until, again, really next week, other than a potential nor'easter, but the models have been more consistently shoving that off the coast, other than a bit of rain across the southeast, which it's kind of doing right now, as you can see. We're starting to do that. I do want to say that the northwest will be kind of continuously getting a bit impacted by systems and storms, so I do say quiet and dry. Again, that's relatively for most of the United States, not for everyone. And again, you can see that's that energy that's gonna again feed into that system. You can see it comes across, and there's a Canadian. It develops its first system. You can see it's mainly rain. If you recall, the GFS develops this one really quickly, and it scoots it off and only explodes it across this portion. The Canadian, it does not do that. It develops a system, but it keeps it more across the central U.S., dragging in colder behind it, producing an absolute massive moisture plume across the northeast, but really just staying mostly rain according to this model of the Canadian. But again, it hasn't been consistent itself, and you can see that in the last time frame, there's a lot of moisture out west, a lot of colder left behind. You could assume that would produce another winter storm, or give way to an easier winter storm scenario. It wouldn't be just all rain because of the more presence of cold air. Again, it's just one model run, and let me just show you the Canadian model run from 12 hours prior to that. This model only comes out 2 times a day, so there's a 12-hour difference versus the GFS that comes out 4 hours a day, which that means there's a 6-hour difference. So this is the one from midnight yesterday. I didn't show you this in yesterday's video, but I can show you it today. And notice, it keeps it dry, right? But it does introduce that pattern. And look, ironically, it was further out. It was, today you'd maybe think, oh, they got into a bit more of an agreement. Look, this is more resembling of what the GFS shows today. And the Canadian today doesn't show that. This is what it showed yesterday. So it's weird. It's almost like if it resembled more of the GFS yesterday instead of today. Again, kind of agreeing one day, and even just because they're agreeing doesn't mean that they're going to continue agreeing. So you can see kind of in a similar fashion, though it does end up developing a pretty large system. Again, mainly rain-free, but it sets the scenario for a potential snowy outcome if that system either lingers behind and develops kind of a new shoot of precipitation, which you could see the Canadian starts doing right there. You could see right there. Obviously, that would probably swing to the north, maybe produce a snow system, but again, it only goes out to 240. It's definitely there. It definitely a storm, but this is the older model run. The newer one shows kind of what I would predict off that old one. Again, except, again, is that really what's going to happen? Is that just a one-time thing? It's hard to tell, but I think that's what makes the weather really fun. Okay, European model. Potentially, the holy grail of all models. It is very good, very accurate. At this point, I would say, though, it is probably as accurate as a GFS. Some people may not agree with that, but that's my opinion. The European, let's take a look at it. Again, it shows that nor'easter across the southeast, moisture across the northwest, keeps it relatively dry up until next week, Wednesday. Really, that's when activity may start steaming up because it continues across the northwest, but now it just extends more into the eastern portion. So let me continue playing this. Look with what it does with the system. Similar style what the GFS does. It speeds it out. If you recall, the latest Canadian kind of develops it into a large storm around this time frame. The European speeds this first little guy out, and boom, it doesn't even intensify. It doesn't even have time to intensify in our kind of viewing area. Maybe once it reaches the Atlantic Ocean and zooms up towards a kind of Greenland area, it may have a bit of an intensification period or whatnot, but that doesn't really concern us. And notice what it does do, though, European. It doesn't waste any time. It takes the next set of moisture and explodes the system out of this one. And actually, the European kind of makes the largest snowstorm out of all the models. Because the Canadian, if you recall, it shows a bit of snow with that system, but it's mainly a massive rainstorm that could set the potential for another big snowstorm because of the cold air that it leaves behind. The GFS, it showed several smaller systems that are potent and will drop a lot of heavy snow in areas that they fall through. They're just not massive. The European shows a singular massive beast. It is very strong. That is a 987 millibar low pressure. Again, nothing we haven't seen before. Every winter these occur, but again, the first one that's kind of across this I don't know, just the first one in the winter during, in fall. Approaching winter is always something, I guess, more magical about it. Notice a lot of snow. This would obviously produce blizzard conditions. This is a classic, blizzard setup. Would this happen again? It's hard to tell at this point. I would say though that again, that's why I'm titling the video "A Very Large Storm System May Be Coming," because even if the GFS shows like several systems, each one of them will probably be pretty darn large. And if it is just one, well, then the title still holds true. And I would be absolutely, shocked if the pattern were to be quiet at this point. I mean, there's not a single model that shows a non-active pattern, and the potential definitely exists. It's just kind of a matter of what results of it. Yes, it could lean towards more inactive, right? These systems become smaller and whatnot, but it seems unlikely. It's just a matter of what the models kind of do with them. Notice the European blows the system away once the weekends rain for the Northeast and for Canada, but the lake effect does kind of get a bit awakened in its wake. And I do want to say that, there's still moisture to the south here across the Gulf of Mexico, a bit of cooler air. It's interesting to see what the European would show in the next hours after this 240 timeline. I will show you the snow actually amounts from this one, because the European really does show a lot. So I think it's also always cool to show these, and you can see in that relatively narrow band, which again on a snow map it may not look as impressive because it's just one band, but you saw that system. It was a honking giant, and you can see in some areas. It would definitely have the capability to drop over a foot and a half, maybe even 2 feet. So, yeah, that's what the European shows. This is what it showed last night. I'll just show you the snowfall totals at midnight. You can see it was much more different of a scenario, where the snowfall amounts were much lighter, and I'll show you what that looked like kind of on the map in terms of the precipitation type and radar. It still showed a massive system, except again, you can't really always gauge what they will show based off that snowfall. Based off that snowfall, it looked like a measly little storm, and again, that's possible in terms of the snow perspective side of it, but really you saw what it produced in Canada. It produced a lot if you looked at that snowfall map. So let's see what it showed yesterday. Again, this isn't the newest information, so it has already changed its mind. It's extremely bipolar all-weather models. That's like what they're born with. It's not like a personality trait. It's like a given, right? And notice that, look at this. I mean, it develops into a big storm. There is snow on the backside. There is a lot of cold air. The lakes do get turned on. And again, look what it does across the Northeast. Just extreme intensification. So again, kind of classic to what a La Nina usually brings during especially the early part of the winter. You can see these big systems that kind of drive from the northwest with that northwest flow. Will we continue this into December, January, just more amped up? Will we, I would say just a year of extremes is probably on its way, but that doesn't necessarily mean snow and cold. But you could see it could mean extreme rainfall maybe for some areas. If such a system were to occur, that would be definitely several inches of rain for the Northeast right there. Let me just take a look at that total accumulated precipitation to show you. Yeah, you could see 2, 3, and that's not even encapsulating the whole system. Look at the Northwest. Gorgeous amounts of precip. You can see here really the Southwest kind of missing out. From the newest model run of the European, though, you can see that the rainfall amounts do slightly increase towards the Southwest. So again, the variation kind of in which areas do see more of it or less of it also vary. Not just a single storm, just a more entire pattern. You can see it's more centered across the Midwest with that beast of a system. So it's been consistently showing that so has the GFS, so has the Canadian. And I was looking at the ensembles, and I'm recording this video a bit early because later I wouldn't have time. So the ensembles from the European haven't come out yet. I looked at the ones from midnight, but again, I mean, they all show what they used to show. They just show systems all over the place. Some show snow across the Midwest, some don't show at all. So I'll show you in tomorrow's video where maybe they get a bit more confidence. And the GFS ensembles are just the same, showing systems here and there passing through, giving heavy snow amounts to some areas, to some none. It's all kind of a mess, but it's what they usually do before they decide on anything. This is what the GFS shows in terms of snow. You can see quite a vast area covered in snow. You can see those several blizzards potentially across the Northeast and southwestern Canada. Eastern would definitely add up to snow. Look at these amounts right here. Those whites, that's off the charts in terms of snowfall amounts. Yellowstone, the Bitterroots, the Cascades, the Sierras picking up decent amounts. And even the Midwest right there. So again, and it does change pretty frequently, the GFS. Look at that change. I mean, that's extraordinary from one model run. And look at that one. Yesterday evening. This was yesterday at 12, so 24 hours ago. This is what it showed. This is now what it shows. Again, stay safe, folks. We'll catch you all in the next episode. See ya. Bye.